The topic of this video is solving logarithmic equations. Let's look at a problem. Solve 4e raised to the x plus 1 power equals 5. Okay, so once again we find ourselves wanting to solve an equation. This time we note that the variable x, which is what we're trying to solve for, is up in the exponent. So here's a piece of advice. Variable up in the exponent, use the converter. The converter can help us when what we're trying to solve for is up in the exponent. But we have to be careful. This is clearly an exponential statement. The word log is not included, which means we're going to use the right-hand side of our converter. But our converter only has space for three things: a base, an exponent, and an argument. In our equation, we have four things. So let's step through this carefully. First of all, what's the base? If you said e, you're correct. The base is e, not 4e. If we wanted the base to be 4e, then both the 4 and the e would have to be put in parentheses in order to indicate that. Since those parentheses are absent, that means that the base is e. So, e is our base. X plus 1 is our exponent. 5 is our argument. So what does that make this 4? That means this 4 is simply extra, and it's something that we have to get rid of before we can use the exponent side of our converter. We do that with division. Divide both sides by 4. Then these 4's cancel to 1. Anything times 1 is itself, anything divided by 1 is itself. So on the left we get e to the x plus 1, and on the right we get 5/4. Now we have what we need. We have a base, which is e. We have an exponent, which is x plus 1, and we have an argument, which is 5/4. We can put these in our converter on the exponent side. E raised to the x plus 1 power is equal to 5/4. Matching up colors and shapes, on the left we get log base e of 5/4 equals x plus 1, which we can write here. Log base e of 5/4 equals x plus 1. Notice that this gets us one step closer to solving for x. X is no longer in an exponent, now it's down on the ground. What we have now says what x plus 1 equals, which is not what we want. We want to know what x equals. So, I want you to imagine that I'm covering up the left-hand side here. That could say anything, like 5 or 12. If it did, how would you get x alone? You would subtract 1 on both sides. So that is exactly what we're going to do. We're going to subtract 1 on both sides. So we have log base e of 5/4 equals x plus 1. And we're going to subtract 1 on both sides. So minus 1 here and minus 1 here. This plus 1 and minus 1 will cancel to 0, because when you add or subtract the same value, that cancels to 0. And this tells us what x equals. X equals log base e of 5/4 minus 1. Now, in a previous video, I said something about a brick. A brick is used to connect the word log with the base and the argument, and nothing outside of the brick can affect anything inside of the brick. So as we now begin to write our final answer, we're going to recognize that this subtract 1 is outside of our logarithm brick, and these two numbers, the e and the 5/4, are inside our logarithm brick. Those cannot interact with one another. So the only thing we can do to write our final answer in a slightly different form is to recognize that log base e is the natural log. So we'll say that the natural log of 5/4 subtract 1 is equal to x. We can even get a decimal approximation for this value using our calculators. So, the natural log button on this calculator, the TI-30XS Multiview, is in the far left column, third button down. So I'll hit the LN button, then I'll do 5 divided by 4, close parentheses, then I'll put in my subtract 1, enter. And I get negative 0.777, approximately. This line represents the exact solution. This line represents the approximate solution. As a general rule, math people would rather have an exact number, and most math learning web platforms will only accept an exact answer for a problem. However, sometimes a decimal approximation is appropriate, especially if the instructions for the problem require it. So be sure you are reading carefully when deciding whether to provide an exact value or an approximate value and solving logarithmic equations.